In this video, I will show you how you can set up EasyPBC on your ABAQUS and how you can have it in your main plugin menu in ABAQUS here. So first of all, once you receive EasyPBC, you will have in the file a couple of things. So you will have inside the main folder an example of EasyPBC, which is the example I'm going to be running here, and you will have EasyPBC user guide and license files. These are the main files that you're going to need to copy into your work directory, which is usually located in C temp file, and you can just paste it here. Once it's pasted here, you can run ABAQUS, and you will notice that the plugin is now available in the plugins menu in ABAQUS. So we can do that here. So if you go to plugins, you'll see that EasyPBC is there. And I'm going to be talking about all the details of EasyPBC when we're going to run them and when we're going to do the model. So in this example, I'm going to be doing a fiber matrix composite example, and these are the properties of the composite, basically the fiber and the matrix. We're going to start off by creating a part with an approximate size of 1. I'll start doing the corners of the part, so I'll start with 0.5 and 0.5 again, with the minus 0.5, minus 0.5. You can do your part in any way you want or any size you want. I'm going to give it a depth of 1, and this is the outer side, the outer shape of the RVE. Now I'm going to create the fiber, in this case, circle in the center of the RVE with the radius same as here. I'm just going to copy this number, and I'll use X as 0 and paste the number that I've just copied, and that's going to give me the fiber. It's going to be it's going to go through the whole epoxy, so that's going to be 1. I need to keep the internal boundaries as well. So as you can notice that if I rotate it, you will see the sides of the fiber on the other side of the RVE. Now I need to specify the properties, so I'm going to specify the first one, which is the fiber. I'm going to give it density. Here in this case, I'm just giving it a density so that we can make sure that we're using the correct VF ratio. So I'll just give it as 1. And here I'm using inputting the elastic properties, which are basically these. Now I'm going to create the second part, second material again, sorry, the matrix. Again, I'm going to give it a very small density, so the overall mass and density is going to be basically only for the fibers. And these are the same properties that you can see here in our example. Once done, we can create the sections. I'm gonna name it as fiber section and select fiber as the material. Same goes for the matrix. So matrix section, and again select matrix. Then I need to assign these sections. So the first one is fiber section, and the second one is matrix. And you can see the sections that we've just created here. Once done, we need to create an assembly. Assembly is basically adding the part we've just made. So we will have one, we already have one part, and we're going to have one assembly. So as you can see here, this is really important to have one part and one assembly. Third step is basically meshing the instance or the assembly or of a part. You can use various techniques to do that, but basically the easiest one is going to be using sweep technique with the selected element type. I'm going to give it a seed size of 0.1 and I will mesh it. So this is the mesh, and I've explained this in different videos, in other videos, and then where you need to have the mapping, you need to have like an accurate mapping on sides of RVE. So this technique would provide that. In other cases, you need to work on that to get better, or to get very good mapping on opposite sides of RVE. And this all is related to the mapping accuracy here in EasyPBC, which are all explained in the paper that have been published on the theory of the program, of the plugin. I'm just going to here save what we've done so far. So I'm going to name it EasyPBC composite example. As you can see here, it's I need to refresh the instance. I'm just going to keep it here so I can show you one of the errors that could appear if we use EasyPBC if this one was not refreshed. And I think this does happen in some old versions of ABAQUS. I don't think it happens in the new versions anyways. So now the first name, which is the model name, should be the same as this one, and the instance name should be the same as this. I'm just gonna give it a go here so you can see the error that could occur if this was not refreshed. So I clicked OK and says instance is create. Make sure instance is created. It is created, but the problem is it's not refreshed. So if we just double click here, it's gonna be refreshed and should work fine. So we go back again, same names. I'm gonna here change the number of my CPUs. In this laptop I have 8 CPUs. If you use a larger number, that's going to create an error, but it's not going to stop a program. So if I create 9, you'll see an error message that's going to appear underneath. So everything is fine. So I clicked OK. As you can see here, there is a warning. The specified number of CPUs is greater than the available. So 8 CPUs are used. So this can be useful for you to know how many CPUs you've got on your system. And as you can see down here, EasyP has started, and you will see end of set creation. This one was fast here because the mesh size is quite large here, so that's why it happens really fast. But that's not the end of the analysis. So as you can see, jobs have been submitted. We need to wait for all the jobs to finish. I'm not going to stop the video, I'll just keep it here. And as you can see, the jobs are running and files being created. Processing speed would depend on your system performance and the number of elements and nodes, of course. This window can freeze, so but it usually keeps on running. So sometimes it can freeze, you can't move anything, but it's fine. one more job, and we should have the results printed in down here. So let's just wait for that. Okay, so all done, and as you can see, there is end of EasyPBC, and you will see here some details on the theory of the plugin. You will see the total mass and the homogenized density as well. And here are the properties, the effective elastic properties. So this is one way of showing the results. There is another way, actually two ways to show the results as well. The first one is the general one. Model name is the same model name that you have in your ABAQUS file, so this could change. And you have the properties again here, and time, mass, density, and so on. And this one is kind of like an easy copy and paste in an Excel sheet. So in Excel spreadsheets. So instead of having all the details and names, you just have the numbers here. And they're like elastic modulus, then shear modulus, and then Poisson's ratio, and time and density as well. So in this slide, I've got some results that have been obtained using the same theory of the program, and the reference of these results is shown down here, down, as you can see. And there are as well experimental data for the same composite that has been used. So I'll just show you a comparison here, a short one, of the results that we obtained and the results available here. So these are our results. That's E11, very close to it. Same with E22. The variations could be as a result of the mesh size we used, because I don't know basically what mesh size we used. But we've compared the results with other programs as well. And that's for shear modulus. You can see some variations in our shear modulus and in E11 and E22, which again could be the effect of a non-symmetric mesh that we've created in second and third direction. And these are the results for Poisson's ratio. And same goes with the experimental data. They are very close to the experimental data. Again, some details on this are mentioned in the paper that explains the theory of EasyPBC. So if we go back again to ABAQUS, and I can show you the jobs that we've created. So in total, we've created 6 jobs, and you can see here some boundary conditions left. So you cannot resubmit the job in your traditional way. And these are the equations, the constraint equations. Again, these are only for shear, so because for elastic modulus they've been deleted, and for shear they're there, so I can delete it, but I've just decided to keep it here. If we go to results and we see, for example, E11, or we see shear modulus, so something like that. As you can see, the geometry is periodic. And that's G23. So should look something like this. In some cases you can't see the deformation, so you need to adjust the deformation scale. So for example, if I want to make it as 1.5, it's going to be more extreme, and you can see the deformations even more. Again, you have all of your job data here, so you can extract basically any data you need out of these jobs that has been submitted. So you have full control of the output of the jobs. So thanks again for watching, and I hope this plugin would be useful for your work, for your research.